All right, in order to graph sine inverse, let's start by actually looking at some points that are on the graph of sine of x. Okay, so some really easy points to see here are minus pi over 2, comma, minus 1. Another easy one is 0, comma, 0. And another easy one to see is pi over 2, comma, 1. And if we were to think about what this would look like if we were looking at the corresponding graph of the inverse function, is what we would see is the x and y values swapping, right? So this is now minus 1, comma, minus pi over 2. And if you swap 0 and 0, well, that's still 0 and 0. And 1, comma, pi over 2 for the last one. Let's go ahead and plot these. Okay. So we have 0, 0 still. And then we have minus 1, comma, minus pi over 2. So that's down here. And then we have 1, comma, pi over 2, which is up here. Okay. And there's one last thing that we need to know about inverse functions before we can finish this off, at least finish this quickly. Okay. And I'm going to jump actually back over here. Let's say we were looking at this example up here again, the natural log of x and e to the x. If we were to graph both of these, there's something interesting that happens. All right, so let's say we were going to graph e to the x first. Well, it's going to look something like this here. And if we were to graph the natural log of x, well, it looks, I'll start right here, it looks something like this. Okay, and is what I want you to see, even though my graph's not perfect here, is that a function and its inverse are just reflections of each other across the line y equals x. And I'll try and put that line in here. Should just be this one that runs right through the origin. There we go. And so hopefully those look like, again, reflections of each other. The green one was y equals e to the x. And the blue one was the natural log of x. And we'll scoot back over here and we're going to use this idea. So we have 3 pink dots there to kind of help guide us. But all we really want to do is just imagine reflecting this across the line y equals x. Okay. And so our graph's not going to be perfect doing this by hand, but hopefully we'll see the idea. And that's definitely not perfect, but okay. So that pink line actually looks like what sine inverse looks like. Maybe we'll graph this on the calculator here in a second. All right, before we enter both of our equations into the y equals, let's adjust the windows. And the only reason I'm doing that is my graph will pop up before I actually hit graph. So I'm going to hit window here. And let's adjust this so that we have the exact same window that we use when we sketch this by hand. So we went from minus pi over 2 to pi over 2. And now our scaling really wasn't consistent here, right? So for the scaling, I'll just input maybe pi over 4. And then for y min and y max, I'm going to do the exact same thing. So minus pi over 2, and then pi over 2. And one thing I want to remind you of, because this messes people up a lot, my cursor right now is hovering over that negative sign. So you want to make sure that you use actually the negative sign as opposed to the subtraction sign. If you put the subtraction sign there, it looks almost the same, but your calculator won't be happy. All right, and then our y scale here, again, let's keep that the same. Let's just do pi over 4. Okay. And now we'll go to our window, and let's start off with just sine of x. Okay. And let's also make sure that we are in radians. Okay, I'm in radians. And I'm going to just graph this one for now. Okay. And coincidentally, this is in blue, just like when we did it in the notes. All right, and next, that seems to match what we have though. Next, let's put in that inverse trig function. So I'm going to do second sine of x. Okay, and now if I hit graph, hopefully this will look like the pink one that we sketched in. All right, looks pretty good. Looks better than the one that I sketched, but yeah, we can see that it looks like it is reflecting across the line y equals x. And we can check this. I just put in y equals x and then hit graph. There we go. And if you zoom out, you'll actually see that restricted domain. You can actually already see it in my table. Let's do zoom out just a little bit. Let's go in the maybe x direction. Let's just make it minus pi to pi. I'm just doubling it. And let's do the same in the y. Minus pi to pi. And we'll just leave the scaling the same for both of those. Okay. And if I hit graph now, you can see that sine continues, right? We're seeing more of the graph of sine right now. But you can see that sine inverse doesn't go very far. Okay. I want us to do the same thing here with cosine inverse that we did with sine inverse. Let's start off with y equals cosine of x. And we're going to talk about first the restricted domain. In order to get cosine of x to pass the vertical line test, we've had to restrict ourselves actually from 0 to pi. If we tried to use the same interval, minus pi over 2 to pi over 2, that we use for sine inverse, we wouldn't be able to pass the vertical line test. Okay. So this is key here. This is why the domain, we've chosen it to be 0 to pi. Okay. So next we have the range. And over this domain, we're going to cover all possible y values, minus 1 to 1. And while we're at it, let's give this thing, let's graph it. So cosine of 0 is 1, cosine of pi over 2 is 0, and cosine of pi is negative 1. There we go. And also, let's put in some of those points that we're going to want here in a minute. So we're going to want to work with 0, 1. We're going to want to work with pi over 2, 0. These are just those nice points. And then pi, minus 1. Okay. And let's move to cosine inverse. So remember, if you are moving from the function to its inverse, you just swap the domain and the range. And similarly, we are going to swap all the x's and y's with these 3 points. And if we do that, we end up with 1, 0. Why don't we graph that one? 1 comma 0, that's right here. And then 0 comma pi over 2, which is up here. And then one more, minus 1 comma pi, which is all the way up here. Okay. Now, this one can be a little bit more confusing to try and imagine rotating across the line y equals x. So maybe I'll put in the line y equals x. Okay. There we go. So what I want us to do now is try to imagine flipping this piece that's above the line y equals x across the line y equals x. If we did that, we'd end up with something that looked like that. Okay. Again, my scaling's not perfect, but we should get a good idea of what this looks like. Okay. So we've taken care of one piece. Let's try another one. Let's try this blue piece right here. That's in between the x-axis and the line y equals x. If we reflect that one, that'll look like that. Okay. And now all we have left is this part that's sitting below the x-axis. And so this one, it's got to travel a little bit further to be reflected across the line y equals x, but it should look something like this. And you can check on your calculator, and what you'll find is this is what the graph of cosine inverse looks like, this pink line here. All right, next we have tangent inverse.